Alex, people look at a pile of copper wires and see a plate of spaghetti, but to me, it's more like a river system. If the water isn't reaching the mill, either the river is dry, the dam is closed, or there's a massive hole in the bank soaking it all up.
And right now, judging by the smell of ozone and that look on your face, I'd say your river just flooded the basement. What happened to the quick weekend project of rewiring the truck?
Every time I say the word quick, the universe takes it as a personal challenge. I was chasing a phantom blinker issue, the kind where you turn left and the radio switches to a polka station. I spent 3 hours overthinking the ECU, when in reality, a family of field mice had treated my ground wire like a 5-course tasting menu.
See, that's why electricity scares me. With woodworking, I can see the crack in the board. With metal, I can see the rust. With wires, the juice is just invisible and angry.
It's only angry if you don't give it a clear path home. Today, we're pulling back the curtain on the magic smoke. We're talking electrical diagnostics and battery health. Because whether you're fixing a 1970 tractor or a modern CNC machine, the physics don't care about the year on the VIN plate.
All right, let's start at the source, the battery. Everyone thinks they're fine until that one Tuesday morning in January when the engine just gives them a pathetic work click and gives up on life. Why does it always happen then?
Because a battery is basically a chemical soup, and physics is a cruel landlord. When the mercury drops, that chemical reaction inside the lead plates moves through molasses. But the real kicker, and this is something that caught me out years ago on an old flathead, is that heat is actually the silent assassin. Summer cooks the liquid out of the cells, but you don't realize the damage is done until winter asks the battery to actually do some heavy lifting. It's like running a marathon with a lung infection you got 6 months ago.
So, if I'm standing in my driveway, staring at a dead car, is there a way to tell if it's the battery's fault or if something else is sucking the life out of it?
The multimeter is your only true friend here. Here's the first hurdle people trip over. A 12-volt battery isn't actually 12 volts. If you put your probes on the terminals and see 12.0 on the screen, your battery is actually at about 25% capacity. It's basically a paperweight. You're looking for 12.6 volts for a full charge. If you're seeing 10.5, you've likely got a dead cell, and no amount of wishing is going to bring that back to the land of the living.
Okay, so if the battery reads 12.6, but the car still won't start, what's chapter 2 of the mystery?
That's when we talk about the lazy pipe theory, or what the pros call voltage drop. Imagine you have a garden hose. The pressure at the spigot is great, but if the hose is kinked or full of holes, only a trickle comes out the nozzle. In a car, your wires are the hose. If you have a corroded terminal, that white crusty stuff that looks like a science fair volcano, it creates resistance.
I've seen that. I usually just pour some old soda on it and hope for the best.
The Coke and a smile method. It works in a pinch for the corrosion, but it doesn't fix a loose connection. I once spent a whole afternoon pulling a starter motor out of a client's Cadillac, swearing it was dead. Bench tested it, worked perfectly. Put it back in, dead. Turns out, the negative cable was bolted to a bracket that had rusted just enough to act like a giant rubber stopper in the circuit. I was chasing my tail because I didn't check the ground first.
You mentioned grounds. Every time I hear a mechanic talk, they mutter about bad grounds like they're talking about a haunted house. Why are they so critical?
Because electricity is a round trip. It leaves the battery, does a job, lights a bulb, turns a motor, and it has to get back to the negative terminal. The car's metal frame is usually that return path. But if you've got paint, rust, or a loose bolt between that wire and the frame, the electricity gets lonely and goes looking for a different way home. That's how you end up with backfed circuits, where your headlights dim every time you hit the horn.
It sounds like a puzzle where pieces keep moving.
It is. I remember this old lathe I bought for the shop. Every time I turned the spindle on, the digital readout would go into a seizure. I replaced the sensors, shielded the wires. Nothing. Finally, I realized the motor wasn't properly bonded to the cast iron base. The noise had nowhere to go. I added one simple braided strap, and the machine acted like it had been to therapy. Total peace.
So, basics first. We check the battery voltage, we check the connections for that white volcano crud, and we make sure the grounds are tight. What about the parasitic draw? That sounds like a horror movie title.
It's the vampire in the garage. It's when something stays on after you turn the key off and pulls a tiny bit of current until the battery is bone dry. Finding it used to be a nightmare of pulling every fuse one by one. But there's a much more elegant way, measuring the voltage drop across the fuse itself.
Hold on, you can check a fuse without pulling it?
Absolutely. Every fuse has a tiny bit of internal resistance. If current is flowing through it, there will be a microscopic drop in voltage from one side of the fuse to the other. You set your meter to millivolts, touch the two little metal pips on top of the fuse, and if the meter jumps, you found your thief. It's like seeing a warm footprint in the snow. You know someone just walked by.
That's actually brilliant. It beats my method of just disconnecting the battery every night and hoping for a miracle.
Well, your method works, but it's a bit like taking the front door off its hinges every time you leave the house to make sure no one sneaks in.
Let's talk tools for a second. If I'm a weekend warrior or a maker just starting to dabble in bigger machinery, do I need one of those $1,000 tablets the dealerships use?
Good heavens, no. Those things are fancy, but they're often just a crutch for people who don't want to learn Ohm's law. You need a decent digital multimeter. Doesn't have to be the gold-plated version, just something reliable. And a simple test light. Beyond that, the most important tool is a good wiring schematic.
Schematics look like secret code, Tiger. I've opened those manuals and immediately felt my brain turn into mashed potatoes.
I get it, it's intimidating. But don't look at the whole page. If the power window isn't working, find the window motor on the map and work backward. Use a highlighter. Follow the river back to the lake. I once had a project where I couldn't find why a fuel pump wouldn't prime. I spent 2 days staring at the harness. When I finally found a PDF of the original 1980s blueprint, I saw that the power for the pump went through, of all things. The oil pressure switch. It was a safety feature. No oil pressure, no fuel. I was looking for a broken wire when I should have been looking at a $10 sensor.
So the manual isn't just a suggestion, it's the actual treasure map.
Exactly. And don't trust the colors blindly. Some manufacturers in the 90s must have been colorblind or just had a surplus of purple wire. Always verify with your meter.
Speaking of verifying, any shop disasters involving electricity you're willing to confess to? Preferably something involving sparks?
Oh, pick a year. I think my masterpiece was working on an old alternator while wearing a metal watch band. I knew better. I really knew better. But I was in a hurry to get to a show. I dropped a wrench, it bridged the main battery post to my watch, and for about 3 seconds, I was the heating element in a giant toaster.
Oh no.
I still have a tiny scar where the Lynx branded me. It was a very bright, very loud reminder that 12 volts might not kill you, but the amperage behind it will happily weld your jewelry to your arm. Now the watch stays on the pegboard, no exceptions.
Well, at least you're consistent.
Here's the soul of the matter, Alex. Everything in the shop, the way a plane cuts wood, the way a welder arcs, the way a battery holds a charge, it's all about balance and flow. Most people get frustrated with electrical work because they want an instant answer. They want a code to tell them exactly what to replace. But the beauty of diagnostics is the logic. It's the purest form of problem solving we have. You aren't just a parts changer, you're an investigator.
It sounds like you're saying we should enjoy the frustration.
I'm saying you should respect the process. When that light and finally flickers on, or that engine roars to life after you found that one loose ground hiding behind the intake manifold, that feeling, that's better than a cold beer on a Friday. It's the feeling of actually understanding the ghosts in the machine.
So the takeaway for the folks at home?
Don't fear the wires. Start at the battery, the real measured voltage, not just it looks okay. Clean your terminals until they shine like a new dime. And remember that electricity is always trying to find the easiest way back to that negative post. If you don't give it a good road, it'll make its own, and you won't like the results.
Wise words from a man who was once a human toaster filament.
Exactly. Learn from my singed wrist, folks. It's much cheaper that way.